Oh, we're on already. Hi. I'm a minute late. All right. So what I'm going to do. Okay. What I'm going to do is I'm going to show just. Holy, they go right into it hard here. I'm going to show one example, two examples on 6.4, just to kind of get you familiar with it, so that when I actually go through it on Monday, it won't be like 100% new to you. So I'm going to start on page 263, and then after that, I'll just answer your questions from the last 3 days worth of work, and I'll explain how to get to. Excuse me. I'll explain how to get to the assignment that I put on OneDrive yesterday or this morning for you. Okay, so up to this point, we have been just working with expressions, which means that there's no equality, so we don't have to solve anything. But today, we have to start solving these questions. So here's a question that they give us: x plus 4 over x is equal to 4. Okay, so the difference between an expression and an equality is an equality. One, I work on both the left and the right side. And number two, I'm going to get rid of the actual denominator. When I do an expression, I keep a common denominator, okay? But when I do an equality, all right, I try and get rid of my denominator. So first thing I'm going to do is I have a denominator of x, so I'm going to get rid of it. And to get rid of it, I have to multiply everything by that value. So I multiply this by x, and that by x. Okay, so I multiply everything by whatever the denominator is to get rid of it. Okay, so then this gives me x squared here, plus that x divided by that x gets rid of it, plus 4 is equal to 4x. And then I go back through and I do everything that I've done up to this point, get it equal to 0. Factor it. And then solve for it. So x is equal to 2. Now I do have to remember, because I have a denominator, I have non-permissible value, and in this case, x can equal 0. All right? So the difference between what we've done for the last 3 days and what we're doing today is the last 3 days we kept our denominator as part of it because it was an expression. Today, because it's an equal sign, I want to now get rid of the denominator so that I can solve the question and get an actual value for x that satisfies this equation. All right. So I'm going to look at the first example on page 264, because this one's a bit of a doozy already. So here's how this works. Okay, so you'll notice the first thing that I did, as opposed to rewriting the entire question as it was I factored out the bottom. The denominator is the most important thing that we have to focus on, as it was for the last day or two here. So now, the one thing that we spent time on yesterday was looking at my denominator and what's the common denominator. Well, this has an x minus 7, this is a 2, this has a 2 and an x minus 7. So what I'm going to do, there's 2 ways I can approach this. The first would be to multiply by each individual denominator. That would probably create some work, but save you some mistakes in the long run. The other thing I can do is find out what my common denominator is and multiply everything by that. So my common denominator is 2 times x minus 7. So I'm going to multiply this by 2 times x minus 7, this by 2 times x minus 7, and this by, sorry, it's going to be jammed in here, 2 and x minus 7. Okay? So what I want to do is I want to now get rid of all of my denominators. So x minus 7 divided by x minus 7. I'm left with 2 times x squared plus 25. Add. That 2 and that 2 cancel. I'm left with x plus 5, x minus 7. And that cancels out in its entirety. So I'm left with 2x squared minus 12x subtract 9. All right. Now what I do is I distribute, I FOIL, I do what I can to get rid of all my brackets here. So multiply this through. This is 2x squared plus 50. This FOILed out is x squared minus 2x minus 35. 2x squared minus 12x subtract 9. So now I move everything to one side. I collect my like terms. So I'm going to move all of these over. This 2x squared and this 2x squared are going to equal 0. So I'm left with x squared here. All right. I have 50 subtract 35, which is 15. And then I got to add the 9 to this side. So that's going to give me, sorry, let me do that again. Let me work with the x's. I'm going to add 12x to this side. That gives me 10x. So I'm adding this 12x over to this side. And then I've got 50 subtract 35, which is 15. And then I add the 9, so that gives me 24. Okay? So I subtracted 2x squared, that canceled. I added 12x, that made 10x. I added 9 to 50 subtract 35, which gave me 24. Now, go through. Factors of x squared. Factors of 24 that add to give me 10. My solution is x equals negative 4, x equals negative 4, and x equals negative 6. Now I should, rightfully so, you'll notice in the book is they plug those values in and they check your answers to see if they work, okay? That's a long process. I'm not sure I would do that right away. Let's just get this down first. We don't really have a lot of time, especially when it comes to doing these. In your assignments, you can check them over to find out, to make sure that both of them work. But for right now, we'll just leave it as is. All right. So that takes care of.
Is there non-permissible values with those?
There is that possibility, yes, that there is a non-permissible value. What I would suggest is I would go through the left side and right side. Look in your book on B, on that verifying your solution. You can follow through on that. I don't want to waste time on it right now, checking it, because I'm more focused on how to get rid of this denominator at the start of it. But yes, there is a possibility there's non-permissible values. Okay? So this is where we're going to begin on Monday. I'm going to go back. I'll do working example 2 with you on Monday, and I'll go through that. Now, what I would like to do is let's focus on 6.1 to 6.3 this morning and go through any or all of the examples that you, or the questions that you need to go through. I did, for those of you that are on here, I did put an assignment in OneDrive. I do want it in by noon on Monday. So make sure that you can access that assignment on the OneDrive. There's a shared folder for Precalculus 30. The assignment's in there. I think it's about 2 pages long. So get that in for Monday. Okay. All right. Let's get started. Let's just go right back to 6.1. Let's start and work our way forward. I don't think there was too many questions, but just I'm going to do one last check here. There's about 7 or 8 of you on here. Were there any questions from 6.1 that you want to see done again? So that's on 6.1. Okay. I'm going to go with silence, meaning we're okay. All right. How about 6.2? Were there anything in 6.2 that you would like to see today? I did cover a few of them yesterday, I think, and they were on the video live.
I have a question, sort of.
Okay.
It was like 4D on page 246, and I think I got the right answer. I just didn't foil it like how the book did. Like, are we supposed to foil it to get it down to like?
No. So you had you broke down x squared. Let me just do that. I want it left in its very simplest form. That's the question there, right?
I think so.
Okay. So I cancel these out like that, and I leave it as x plus 1, x plus 3 over x subtract 4. And then x can equal 2 and 4. That's what I want to see. Leave it like that. Don't foil that.
Okay.
Yeah, do not foil that, because to me, like I said, I explained this the other day. Make sure that you're breaking it down to its very minimum, and then leave it as is. Okay? All right. Anything else in 6.2 for you, Amron, or anybody else on here?
Page 247, 5C.
Okay.
You could just take a look at that one.
Sure.
Thank you.
Okay, so I'm going to jump right into FOIL, and then I'm going to also switch my, switch my denominator, or sorry, my reciprocal of that second fraction. So I've got x plus 6, x plus 2 over x minus 7, x minus 8 times 3x plus 2 over x minus 7. All right, so this is another one of these questions that I think the book wrote down incorrectly, to be honest with you. All right. Write each quotient in simplest form. This is the simplest form as you can get. You can't cancel anything. So to me, they should have, if the book was, I think the book wanted this on the bottom and this on the top. So I think there's an error in the way they wrote that question out. That's the answer to that question. And then you would add in that. So I think there's an error in that book, the way they wrote that question, because there's no other way you can simplify that the way it's written.
Okay, thank you.
No problem. Okay. And I'm moving quickly, and feel free to slow it down, go back, whatever. I'm on here for you for at least an hour today, so If you have other questions, you can. Let's look at 6.3 then. So that's where I left you off with yesterday. Are there just questions from 6. Oops, just 1 second here. Just check it out, see. Good. Okay. All right. So 6.3. Any questions in 6.3 that you want to see this morning?
Can you do 4E on page 258?
Sure. 4E?
Yeah.
Okay. So I have the factored form of the bottom would be x plus 2, x plus 4, right? Add 1 over like that. And it wants us find the sum or difference as indicated. So we have to actually solve this, correct?
Yeah.
Okay, so what do you see here as being your lowest common denominator?
X plus 2, x plus 4, and then x subtract 3.
Awesome. I 100% agree with you. So what I'm going to do is this. I'm going to write it out. X plus 2, x plus 4, x subtract 3. Okay? So that's awesome. That's the first part that I want to do. Now, here's what I'm going to say to you. I look at this is my whole denominator right here, right? What is this guy missing that this has?
The x minus 3.
Right. So I'm going to times this by x minus 3 and this by x minus 3 like that. So that gives me x minus 3 here plus.
Okay.
Okay. Now what's this one missing?
The x plus 2.
So I times the top and the bottom here by x plus 2. That gives me x plus 2 like that. So far, so good?
Okay. Yep.
Okay. And now I simplify the top part. So that's giving me 2x minus 1 over x plus 2, x plus 4, x minus 3. Write my non-permissible values in. Minus 2, minus 4, and 3. And that's it. I'm done with that question.
Oh, okay. I thought maybe you had to do something with the bottom too. I don't
know. No.
Okay. That makes more sense.
Okay. So when you're doing expressions like this, all you want to do is get it down, break it down as low as you can. The only other thing that you would do is if there was, let's say there was a quadratic on top when I do all the multiplying, and I can factor it and maybe cancel out. That's the only thing I do. Right now, leave that bottom as is. Okay? Any other questions on that, Morgan, that you want to look at?
No, I don't think so. I think I was good with all the other ones I did.
Okay. All right. Anybody else online want to see any of the other questions from 6.3 this morning?
Can we do 5D? 259.
5B?
D.
D.
B, yeah, B, sorry.
The backwards D? Is that the one you're talking about? All right. Sure. Okay. So 6x minus 19 over x minus 4, x plus 1, add x minus 5 over x minus 4. Okay. Were you able to factor it to that? X minus 4, x plus 1?
Yeah.
Okay. So what's your common denominator here?
X minus 4.
Yeah. And x,
Okay.
x minus 4, x plus 1. That's my common denominator, all right?
Okay.
Okay, now I go 6x minus 19 because this one's already full. I've got the same thing here and here. And then this guy, what do I have to multiply this guy right here to get the same as the denominator down here?
X plus 1?
That's right. That's right.
Okay.
Be confident. Be confident. That's right. X plus 1, x plus 1. Right? Whatever's missing is all I have to do. So then that gives me x minus 5 times x plus 1, like that. Okay? So the first thing is to establish what that common denominator is. And then the second thing is, what is it that that one's missing? So that's what I work with. In this case, x plus 1 over x plus 1. So now I need to actually FOIL this out. So to speak to Amron's comment earlier, this is where I would FOIL something out. And all of that is over x minus 4, x plus 1. I have to collect my like terms now. So I've got x squared, 6x subtract 4x is plus 2x. And minus 19 subtract 5 is minus 24. All over x minus 4, x plus 1. Now here's the thing. I have to look at the top part. Now that I have another trinomial quadratic, I have to look at the top part, factor the top part. So it looks like it is. I can factor it to x plus 6, x subtract 4, and all of that is over x minus 4, x add 1. And then what do you notice about that fraction?
X minus 4
Mm-hmm.
on top of the 1.
And on the bottom, so I cancel those out. So my final answer for all of that work is that, and then whatever my non-permissible values were, which were 4 and negative 1. Okay?
Okay.
So let's just kind of go back through it just to make sure we understand. So the first thing I did in red here, when I wrote it out, is I factored my denominator so that I can see all of the possible values that would be my denominator on the bottom, right? So I got x minus 4, x plus 1. Then I look at the denominator and I compare it to my common denominator. And I say, okay, well, what's my denominator missing from the common denominator? Well, in this case, it was nothing. In this case, I was missing the x plus 1. So I have to multiply this denominator by x plus 1. I also have to multiply the numerator by it. Whatever I do to the bottom, I have to do to the top to keep it the same. All right? And then, once I've done that, I have to simplify my numerator all the way down as far as I can. And in this case, when I simplified it down, I was able to factor it and then cancel out at the very end. All right?
Okay. I just have a question for what you just did.
Sure.
When you FOIL to like x minus 5, like in x plus 1, what did you get for your thing? Did you get like x?
Right here. X
I just
squared.
can't see it.
X squared subtract 4x subtract 5.
Oh. Okay, yeah.
Okay, here, let me do it on a bigger board. So I've got x minus 5, and I'll do all the steps. Again, I'm doing this, I'm shortcutting in my head here. So x times x, x squared. x times 1, 1x, minus 5x, minus 5, x squared, minus 4x, subtract 5.
And then you broke that down to x minus 5 and x plus 1?
No, I left it like this, Amber. So I stuck it in, and then I combined it with 6x subtract 19 at the start of this, right here.
Okay, so then you got x squared.
I had x squared subtract 4x subtract 5. So now I have x squared, and then I went 6x subtract 4x gave me plus 2x. And minus 19 subtract 5 gave me minus 24.
Over x minus 4 plus, or like x plus 1, right?
Yeah, that's right.
And then that's all you did? Or then did you break it down?
Yeah, then I could factor x squared.
And then they canceled out.
That's right.
Okay.
That's right.
Cool.
Okay?
Okay, I have a question about like the start of it.
Sure. Let's go back up.
Like, okay, so like at the very start of the question, when you like factored the first denominator, you have like x minus 4, x plus 1, and on the other side you have x minus 4.
Yeah.
How do you know when to just like leave the lowest common thing as x minus 4, x plus 1 instead of like x minus 4 squared? Like when do you put it in the bottom twice? Do you know what I mean?
Yeah, I do know what you mean. Give me 1 second here. I did an example yesterday. Just looking.
Yeah, where it was like in there squared or whatever.
Yeah.
Now, like on all of them, when it's there twice, I put it squared. But
okay, let me show you how to. Okay, let me show you the easiest way to make sense of that. And that's this. Okay, so I'm hoping you can see this all right.
Yeah.
All right, so let's compare the two denominators right now. And the first thing I always do, this is called a Venn diagram. And the only thing I'm missing is the whole square and stuff, but whatever. These are circles that we use. I always start in the middle. What do both of them have? Well, they both have x minus 4. Agreed?
Yeah.
Okay. And what does denominator 1 have that denominator 2 doesn't have?
X plus 1.
X plus 1. And what does denominator 2 have that denominator 1 doesn't have? It doesn't have anything, right?
Yeah.
So because this is all I've written, it's x plus 1 times x minus 4.
Okay.
Okay? Now, if let's say I had, I got to do this off the top of my head, so bear with me for 1 second. Let's say I started with, I don't know, doesn't matter what I have up here, I'll just use 1 up here. So let's say I had this minus 8x plus 16, add 1 over x squared. Oh, shoot. Second of minus 3x minus 4. Minus 3x minus 4. Okay, so here's the question I have. All right. So the first thing I want to do is I want to break down the denominators in both of these. So let's do that. And what I find out here is I have x minus 4 times x minus 4. And over here, I have x minus 4, x plus 1.
Okay.
So far, so good. You following me? Okay. So what's common between D1 and D2? What's common between the two denominators? They both have what?
X minus 4.
All right. So I stick one of those x minus 4s in here. This one has an x plus 1, right? And this one has an x minus 4, an extra one. Okay? So now in this question, my denominator would be this: x minus 4, x minus 4, x add 1. So in theory, I would have an x minus 4 squared here.
Okay, yeah.
Okay? So that's where I would use it, where they would be squared. Otherwise, you just write them as singles all the time. Now, I don't even need to worry about that, Amy. I would just leave it as I have written here. Even if they are repeated, just leave it like that. That's still in its common, most simplified form. So rather than writing it as x minus 4 squared and making it all confusing, just simply write in the x minus 4 as single terms. Okay?
Okay.
All right?
Yeah, that makes more sense.
Okay, perfect. Perfect. All right, anybody else want to look at any of the questions on 6.3?
Maybe question number 7 on page 260, if you could, please.
All right. Okay. These guys are going to cause a little bit of problem, or at least some difficulty. At Nathan's Deli in New York City, there's an annual hot dog eating contest. Contestants have 12 minutes to consume as many hot dogs as they can. Suppose you can eat an average of n hot dogs per minute. Write an expression for the number of minutes it would take to eat 5 hot dogs. All right. I'm going to cheat for this question. I'm going to look at the back because I got to get this. To explain it properly, I need to make sure that I'm doing it right. So let me just have a look back here. This is 6.3, right? And this is question 7. Okay. Okay. So contestants have 12 minutes to eat as many hot dogs as they can. Suppose you can eat an average of n hot dogs per minute. So write an expression for the number of minutes it would take to eat 5 hot dogs. So the rate then is number of hot dogs, right? Over number of minutes. That's what your rate would be, right? So we don't know how many minutes it is. So I'm going to take 5 hot dogs because I do know how many of those are, and I divide it by n. So that's an expression. So n can equal 0. That's the expression, 5 over n. All right, so it's 5 hot dogs per n minutes. All right, to find out the amount of time. Let me do this. Let me change this just a bit here. The amount of time it takes to eat these hot dogs. You take the number of hot dogs per minute. That's more like it. Okay? So to find out the amount of time, I take the number of hot dogs I can eat, and I divide it by the number of hot dogs I can eat per minute. So when you actually divide them, I'm going to end up with the number of minutes up here. So I've got 5 hot dogs over my rate, which is n hot dogs per minute. Okay?
Okay. Yeah, thank you.
All right, so now it says, suppose that after you've eaten 5 hot dogs, your average rate of consumption slows down by 1 hot dog per minute. Write an expression for the number of minutes it would take to eat the next 5 hot dogs. So I have 5 hot dogs, and my rate is slowing by, it's going to take me 1 extra minute, is it not?
Yes.
So would I go n plus 1 or n subtract 1?
Plus 1.
Right, because it's going to take you 5, it's going to take you a number of minutes longer. So then that's the case. So n can equal -1. So 5 over n plus 1. Okay, so that's my time. So it's asking me for, how do I find an expression for the amount of time it's going to take to eat the 5 hot dogs? That's how long it's going to take.
Okay.
So far, so good?
Yes.
Okay, so this is just your introduction into it. This is going to get better as it goes. But these questions are, we're going to need to spend some time on them for sure. Although they have n-1 for this. So let me do that again. Let me read this over. Okay, so 5 hot dogs per minute, your average, oh yeah.
Wouldn't it be n-1 because
Yes.
if like the number of hot dogs per minute goes down, that means it's slower.
That's right. You're absolutely right. Okay, so this can't equal 0, right? So you gotta have number 1. That's right. So this is going to be 1 less minute. Okay, because you're gonna go, so if you're, like, let's put it into perspective. So let's say you ate 6 hot dogs per minute. Now you're only gonna be able to eat 5 hot dogs per minute. So I'm comparing, the n is the number of hot dogs I can eat in that minute. So I'm now eating fewer amount of hot dogs per minute. So I have to actually subtract 1 off of it. Does that make more sense, Austin?
Yeah, thank you.
Expressions in simplest form representing the number of minutes it would take to eat 10 hot dogs. Okay, so I would then add these guys together. So to write that for that C part, I would have 5 over n plus 5 over n-1. There's my expression, right? Just going to take that to the next page. So to find the amount of time, all right, now I would get a common denominator. So my common denominator is n times n-1. So I get 5 times n-1 here, plus 5 times n. You get 5n, subtract 5, plus 5n, all over n times n-1. That gives me 10n minus 5 over n times n-1. And I could leave it like that. All right. You could factor a 5 out. I could factor that 5 out and leave it as 2n minus 1 over n subtract, or n times n-1. That's also okay. I would accept both of these. Now the back of the book would have you multiply n times n-1. I wouldn't do that. Leave it as is, like this. Okay?
Okay. Thank you.
No worries. No worries. Okay, anybody else want to look at 6.3? My buddy's back on.
Could we do 9B on 262?
9B? Yeah, for sure. Okay, so again, Tessa, I'm going to go through and do the, I'll do the factoring, and what I want you to do is stop me if you think if you see an error compared to what you were doing there, okay?
Okay.
All right. So factoring wise, how does that look to you?
Looks the same. It's good.
Okay, perfect. So now what I want to do is, again, you're using BEDMAS, so you're doing the multiplication first. So now what I'm going to do, again, I should probably do my non-permissibles. So my non-permissible would be 0, -10, 7, 6, and then -3/2 there would be my non-permissibles. So now I go this, those cancel. That cancels, that cancels, that cancels. So I'm left with x plus 3 over x, subtract x plus 5 over 2x, add 3. All right, what's my common denominator?
X.
And
2x plus 3.
that's right. Perfect. Okay, so what do I multiply x plus 3 by?
2x plus 3.
Yep. And what do I multiply x plus 5 by?
X.
Exactly. Okay. So I've got that. So now I have to FOIL. I'm going to put it in a different color. So 2x squared. That's 3x, 6x makes 9x. Plus 9 minus x squared, subtract 5x. Okay, so what I've done is I FOILed this, and then I distributed my x through the brackets. Now I collect my like terms. 2x squared subtract x squared is x squared. 9x minus 5x is plus 4x. And then I think I just have 9 here. Does that look right? Just gonna take a look. I feel like I should have canceled something else out.
Yeah, that's right.
Yeah. And there's your answer. And then I add my non-permissibles. Minus 10, minus 3/2, 0, 6, and 7. And there you have it. Okay?
Yep.
Right on. All right. Any other questions?
Thank you.
You're welcome. Any other questions?
Is there any chance that we can have the assignment pushed back to Tuesday by 12, just because Monday's Easter Monday and stuff?
Oh, okay. I don't care. Sure. You should actually, in all honesty, if you took it right now, you'd probably have it done by lunch today. I think there's not that many. There's 6 or 7 questions only.
Yeah, and I probably get it done before you forget everything. So yeah.
Yeah, but I mean, yeah. What it comes down to is I'll post the answers at noon on Tuesday. Then, well, actually, I'll post them at noon on Tuesday, which means I won't take any other ones in after that point once I've posted the answers. But if you work at, sorry, go ahead.
The chapter 5 assignment, did you just give us March for handing it in?
Yeah, because the way they were handed in was an absolute mess. I was getting half pictures, and I was getting so I'm trying to. What I would ideally, like, everything else has been running okay this week. I'm just trying to figure out the best way to get you an assignment and get the assignment back so it's easy for both of us. So I'm hoping this OneDrive works slick, and then it's easy for me to mark it. But the other one I had, individual pages, and I had some pictures cut off, some pictures I couldn't actually see. So it was hard. So I was like, okay, well, I'll just give marks for full marks for anybody that handed it in. And then now we'll try and actually get them, and then I'll mark them and get them back to you so you have a better idea. Okay? All right, any other questions this morning from anybody? Okay, before I go, 2 things. Number 1, this class is going to be at 9 o'clock. I mentioned that yesterday. So I'll be on from 9 till 10 to you from here on in. Mrs. Cowan would like to run her class at 10 o'clock. So I said, I'll flip you back to your actual time. So I know that's not ideal, but it's just the best that we can do. So from here on in, your class, unless I say something otherwise, it will be at 9 o'clock to 10 o'clock from starting Monday. And yeah, and then just has everybody been able to, hopefully everybody's been able to access that assignment from the OneDrive. Okay, that's all I'm really worried about. If there's no other questions, wish everybody a good Easter weekend, and I'll see you again on Monday. All right?
Thank you.
Okay, no problem.
Thank you. See you.
You're welcome. Have a good weekend, everybody. Bye.
You too.